Most of us are lucky enough to take water for granted, and apart from enjoying its scenic qualities, we use it largely without thought. We wash in it, cook with it, drink it in many forms, quite apart from which some 95% of our body matter consists of water. Water is also the most commonly used material in the production of pharmaceuticals, toiletries and cosmetics, products that comply to CGMP, current good manufacturing practice. System design must take into account the quality of the feed water coming into the plant, the quality of water required for the end product, and the total volume required over different periods of the day, for example, each hour, in 8-hour sessions, over 16 hours, or even during each 24 hours. The quality of feed water varies from one country to another, in different parts of the same country, and also from one local site to another. Even when it's variation, incoming water delivered by the local water company may contain microbial contaminants, including bacteria and pyrogens, albeit at low levels. However, as these can develop rapidly, they must be controlled by a water purification system. Pharmacopoeias specify two main water qualities for use in the manufacture of pharmaceutical and other healthcare products. First, purified water, and second, water for injection, commonly referred to as WFI. It can be seen from the chart that the purification process is divided into 3 stages, starting with pre-treatment to remove gross impurities, then the purification treatment, which produces the bulk of usable water, and finally, the production of water for injection, which requires an addition. First, reverse osmosis, the system commonly used to desalinate seawater into drinking water. Osmosis is the phenomenon whereby a solvent, such as water, passes through a semi-permeable membrane which separates 2 solutions of different concentrations. A semi-permeable membrane, reverse osmosis, takes place when this natural flow is reversed by applying pressure to the liquid on the side of the stronger, contaminated solution, forcing solvent to the weaker or decontaminated side. Provided that the induced necessary to utilize a deionization or ion exchange process as the final step in water purification. In this, an ion in one compound is replaced by a different ion of the same charge from another compound. In most cases where deionization is required to achieve purified water, there are 3 alternatives: regenerable deionization, surface exchange deionization, and continuous electrodeionization, WFI, is the only raw material specified by several pharmacopoeias, although a few have now stopped defining the precise method of its manufacture. In practice, distillation is the method of choice as the most secure method of WFI production. Distillation is the process of boiling a liquid, in this case water, and condensing the vapor. The liquid collected is called the distillate. Of purified and WFI water systems follows the same guidelines as for any other CGMP compliance system. This starts with the definition of the system as a whole, of each subsystem, and of each component. The specification, installation, and